Laminar flow is when two layers of fluids flow over each other. It is called laminar because it is smooth. This is because the particles of the liquid move in a straight line so that they do not mix with the other layers like they do in turbulent flow, when a fluid swirls around like a river. It occurs when the fluid flows in infinitesimal parallel layers with no disruption between them. In laminar flows, fluid layers slide in parallel, with no eddies, swirls, or currents normal to the flow itself. In simpler terms, it is uninterrupted flow in a fluid near a solid boundary in which the direction of flow at every point remains constant.
We can predict the laminality of a liquid by finding something called the Reynolds number. It can be calculated by dividing the inertia of a liquid, factors like density and velocity, by the liquid's viscosity. So, by having a liquid that is more resistant to flow, like molasses, will result in a lower Reynolds number, thus having better laminar flow. While vice versa is true, if the liquid is moving at a fast pace, like a power washer, laminality won't be as clean.
To make laminar flow, you're going to need a PVC pipe that's 4 inches in diameter, 2 test caps, a garden hose nozzle, coffee stir straws, screen mesh, scouring pads, and a can of soda. The first step to actually making the laminar flow is to cut the PVC pipe to 1 foot long. Then cut 3 rings of the PVC pipe, each being 1/4 inch wide, and then cut them so they can fit into the PVC pipe. Then drill holes in the caps that are the same size as the threads of the hose nozzle. Now you're going to want to trace 3 circles onto separate scoring pads and cut them all out. Then cut out the screen into squares so that there's a little bit of extra room around the rings. Now using the soda can, cut the top and bottom off so you're left with an aluminum rectangle. Cut that rectangle in half so it's about a square. Then drill a 5/8 hole into the aluminum square. Then cut a circle around the hole with a 1 inch gap between the edge of the hole and the edge of the circle. Then use a high grit sandpaper to sand the hole so it's smooth. Now to actually start assembling the laminar flow model, you have to put the 3 scouring pads into the tube. Then with 1 ring and a screen mesh square, put them into the tube together and cut off the excess screen. Then completely fill the other end of the tube with coffee straws. Then put 2 more layers of the screen and the ring on the same end as the straws. Then with the aluminum square with the hole in it, line it up with the hole you drilled on one of the caps and put that on the straw end of the pipe. Then with the other cap, put the hose nozzle through the hole, and now you have a complete laminar flow model.
Laminar flow is created when water flows in one direction with no turbulence or any disruption, giving it the appearance that it's static even though it flows. In this model, it was intentional that some parts were added to aid in the occurrence of laminar flow. For example, the straws were used to keep the water straight in one direction. Small space right after the straws in the model is used so that no turbulence is picked up. The mesh is used for the same purpose, as turbulence will hinder laminar flow. Also, for the model to work, no air bubbles should be present, as it will cause disruption. Finally, sanding the nozzle is very important because it makes it smoother and helps with laminar flow. This model is a great experiment to show this amazing concept called laminar flow.
Laminar flow is something used in everyday life to save money and save lives. So, to save money, aircrafts usually use laminar flow in order to increase the efficiency and fuel-saving ability of their aircraft. They do this by modifying their airfoils. What they do is they make something called a laminar airfoil, which is different from a normal airfoil because the shape allows it to maximize the amount of laminar flow around the wing and therefore be more aerodynamic and more efficient so they can save money on fuel. Additionally, agencies like NASA and aircraft testers frequently use laminar flow to test our aerodynamic stuff like rocket ships and helicopters and all sorts of stuff that are going to fly in the air in order to make it as aerodynamic as possible. Now, it saves lives because in many science rooms in colleges and even high schools, they use something called a laminar flow hood, which takes air, uses laminar flow to push clean air through a filter, and then laminar flow again all the way through to the user so they can operate and do experiments in a concealed clean environment with clean, fresh air.
And thanks to Keysight, I'd like to give away 1 full bridge rectifier to a school in the comments below. If you haven't entered already, use code APGAR on my Patreon to access even more discount giveaways.